In the last video, we showed how to calculate out the price elasticity of demand. Let's dig a bit deeper into this concept. I'm going to draw two demand curves, putting quantity on the x-axis and price on the y-axis. One demand curve is going to be steeper than the other. The key intuition is that when we're looking at two demand curves, the flatter one is more elastic. Why? Let's look at a small price change. For a small price change here, from the old price to a new price, we get a big change in quantity. We might not know the exact elasticity of this curve, but let's compare it to the steeper demand curve that I drew. A small price change here causes a small change in quantity. If we keep these same two prices, the change in quantity here is much smaller than the change in quantity here. Even a big change in price doesn't change quantity very much. If we were to go from a very high price over here to a much lower price, the quantity demanded would still be less than it is for the flatter curve. So this is a more elastic curve, and the steeper one is more inelastic. Now, what determines how elastic a demand curve is? There's a couple of factors we can think about. The first is the availability of substitutes. If there are a lot of other things you could easily buy instead, then small changes in price will affect the amount demanded for a good by a lot. But if there are few or no substitutes, then demand is likely to be more inelastic. For example, the demand for pizza is likely to be fairly elastic since there are a lot of substitutes, other goods you could have for lunch. But the demand for gasoline is going to be fairly inelastic because there's not a lot of other stuff you could put in your car to make it go. The second determinant is the definition of the market. The concept of substitutes is closely related to this idea. The demand for pizza from a particular restaurant is going to be more elastic than the demand for pizza overall. Pizza from one restaurant is a close substitute to pizza from another restaurant. Similarly, gasoline at one gas station is a very close substitute for gas from another one, so demand for a particular station's gas will be more elastic than for gasoline overall. The next determinant is need. The more a good is a necessity, the more inelastic its demand will be. The demand for life-saving medicines will be very inelastic. The quantity demanded won't change much when the price changes, even for very large changes. But the demand for, say, app downloads is likely to be much more elastic because it's a luxury. They're not really that important. Another factor is the share of the budget. The demand for a good is generally more elastic the larger a share of the consumer's budget it takes up. If a product costs very little and takes up only a tiny share of your budget, then even a large relative increase in its price may not change demand very much. For example, an increase in the price of the $1 pen that you replace every school year probably won't change your demand very much. Finally, adjustment time. In general, the longer the time horizon, the more elastic the demand is. Gasoline prices are a great example of this. If gas prices doubled tomorrow, quantity demanded would definitely go down, but probably not by that much. But in the longer run, people would be more likely to carpool, make different choices about where they live and work, and purchase more fuel-efficient vehicles. The quantity demanded will be more responsive in the long run. Here are some examples of price elasticities of demand from economic research. So for instance, the price elasticity of demand of cars is about 2. The price elasticity of Coca-Cola is about 1.2. Wine has a price elasticity of about 1. Interestingly, beer has a price elasticity of about 0.29. So the demand elasticity, the price demand elasticity of wine is more elastic than it is for beer. In fact, beer is more inelastic than residential water. That is water for home use, which has an elasticity of about 0.38. And gasoline has an elasticity, in the short run at least, that's pretty close to 0.06. Now let's shift gears a bit and look at some extreme examples, perfectly inelastic and perfectly elastic demand curves. I'm going to draw these over here. Let's start with perfectly inelastic demand. And again, we've got quantity on the x-axis, price on the y-axis. I've drawn a perfectly inelastic demand curve. It runs vertically, straight up and down. No matter what the price is, the quantity demanded will always be the same. This amount right here. Remember that the price elasticity is the percent change in quantity for a percent change in price. No matter what the price changes here, the percent change in quantity is always 0 because the quantity is always going to be this amount. So the price elasticity for a perfectly inelastic demand curve is 0. This is an extreme example, of course, but you could imagine something like your demand for water after being lost in the desert for a day as being pretty close to perfectly inelastic. Now I'm going to draw a perfectly elastic demand curve. It's going to run horizontally, side to side. If the price increases at all, consumers will stop buying the good altogether. This is a perfectly elastic demand curve, and this one over here was perfectly inelastic. Imagine there's 2 identical soda machines side by side. The demand for soda from the machine on the right is perfectly elastic. If the price goes up by even a penny, you'll just buy from the machine on the left. In this case, quantity responds infinitely to price. A percent change in price results in an infinite percent change in demand. So the price elasticity here is infinite. That symbol just means infinity. Now there's 2 other elasticity concepts that I'm going to mention briefly. The first is the cross-price elasticity. This is the percent change in the quantity demanded for one good for percent change in the price of a different good. And we can represent this again with an epsilon. And I'm going to put an X for good X and a Y for good Y. Those are the 2 goods we care about. And this is just going to equal a percent change in the quantity demanded of good X for a percent change in the price of good Y. We might be interested in, say, the cross-price elasticity of demand for pizza, good X, with respect to burritos, good Y. A positive cross-price elasticity means that the goods are substitutes. When the price of burritos goes up, the quantity demanded of pizza goes up. Burritos get more expensive, consumers switch to pizza. If the cross-price elasticity is negative, then the goods are complements. For example, the cross-price elasticity of demand for pizza with respect to Coke might be negative. When soda gets more expensive, we purchase less pizza because we like to consume them together. And if the two goods are completely unrelated, then the cross-price elasticity will equal 0. The price of good Y doesn't affect the quantity demanded of good X at all. The other concept is the income elasticity of demand. This is the change in the quantity demanded for a percent change in income. And I'm going to write epsilon M, M for income. And that just equals the percent change in demand for good X over a percent change in income, M. If it's positive, then the higher your income, the more of the good you consume. And remember, we call that a normal good. So if the income elasticity of demand is greater than 0, then this is a normal good. We can take this a step further and say that if the income elasticity of demand is greater than 1, we could even call this a luxury good. If our incomes go up by 10%, but we increase our purchase of the good by more than 10%, then it's a luxury good. For example, if our incomes go up by 10%, but we spend 15% more on, say, champagne, it's clear that champagne is a luxury good. Now, if the income elasticity is negative, it's an inferior good. Because we actually buy less of it as we get richer. You'll probably buy less ramen when you're out in the workforce getting a paycheck than you do as a student. The key to understanding how elasticities are determined and what effect they have on demand is to take a step back and think about the nature of the good that you're talking about. How will a percent change in the price affect the quantity demanded?